It survived everything: concrete floors, washing machines, years in a drawer, battery removed, forgotten, then someone put the battery back in, and it turned on. The Nokia 3310 became a kind of cultural shorthand for indestructibility, a joke, a meme, a myth. But the myth was built in a factory, in a small city in southwestern Finland called Salo. Inside a building most people who owned the phone never knew existed. This is what that building looked like from the inside. In the year 2000, the mobile phone market was moving faster than almost any consumer technology in history. Nokia was at the center of it. The Finnish company had gone from making rubber boots and paper to becoming the largest mobile phone manufacturer on Earth. By 2000, 1 in every 3 mobile phones sold in the world carried the Nokia name. The 3310 was designed to be the phone for everyone who didn't want a phone for business people. It was a phone for students, for teenagers, for people who needed something that worked and would keep working. The design brief was simple, reliable, affordable, personal. The engineering brief that followed was considerably more complicated. Nokia's Salo factory had been producing electronics since the 1970s. By 2000, it was one of the most advanced mobile phone production facilities in Europe. The building covered tens of thousands of square meters. Inside, the production lines ran in shifts that kept the floor active nearly around the clock. The air smelled of solder paste and the faint chemical edge of PCB cleaning fluid. Not unpleasant, exactly, just specific to that kind of building, that kind of work. The 3310 body was made from polycarbonate, a thermoplastic significantly tougher than the ABS plastic used in most consumer electronics of the era. The choice was deliberate. Nokia's engineers had spent considerable time thinking about how the phone would fail. Drop tests were part of the development process from the beginning. Not one drop test. Hundreds. The phone was dropped onto concrete from pocket height, from table height, from higher. It was dropped onto corners. It was dropped at angles that maximized the stress on the joints. Each drop told the engineers something. The polycarbonate housing flexed on impact rather than cracking. The internal components were mounted on a chassis designed to absorb the shock wave from a drop before it reached the circuit board. The battery connected through a locking mechanism rather than a simple slot. It wouldn't eject on impact. Every design decision that made the 3310 survivable was a response to a specific test failure somewhere in the development process. At the Salo factory, the polycarbonate body panels were injection molded in a dedicated section of the floor. The molds ran at high temperature, producing the 2 body halves, front cover and back cover, at a rate that kept pace with the assembly line. Workers checked each piece as it came off the press. Flash at the edge of a cover panel was unacceptable. A visible weld line where 2 flows of plastic had met inside the mold was cause for rejection. The color consistency had to match the batch standard exactly. Nokia sold the 3310 in multiple colors, and the colors had to be the same blue, the same gray, the same deep navy across millions of units. The circuit board inside the 3310 was assembled using surface mount technology. This was different from the through-hole soldering of an earlier generation of electronics. Components were placed directly onto pads on the surface of the board, not through holes. The placement was done by pick-and-place machines, robotic arms that moved components from tape, reels onto the board at speeds a human hand could not follow. Hundreds of components per minute, each placement accurate to a fraction of a millimeter. The populated boards then moved through a reflow oven, a long tunnel in which the temperature rose through a programmed profile, melting the solder paste that had been printed onto the pads before placement, then cooling in a controlled descent that left each joint solid and bright. After reflow, the boards went to automated optical inspection. A camera system scanned every joint on every board against a reference image. Any joint that deviated from the reference, a bridge between 2 pads, a lifted component, a solder ball in the wrong place, triggered a rejection flag. The board was pulled from the line and sent to a rework bench. At the rework bench, a technician under a microscope examined the flagged joint and either corrected it with a fine-tipped soldering iron or scrapped the board entirely. The boards that passed optical inspection moved to the functional test station. Each board was pressed into a test fixture, a bed of pins that made contact with every test point on the board simultaneously. Software ran a sequence that exercised every function: the radio, the display driver, the keypad controller, the audio path, the power management circuit. The test took less than 30 seconds per board. If a board passed, it moved forward. If it failed, it was analyzed, reworked, or scrapped. The keypad of the 3310 was a separate assembly. The rubber dome sheet, the tactile layer beneath the keys that gave each key press its characteristic click, was stamped from a silicone sheet and inspected for tears or misaligned domes before installation. Workers pressed each key on every completed keypad against a resistance gauge. The force required to actuate a key had a specified range. Too light and the keys registered accidental presses. Too heavy and the user experience suffered. Every keypad that left the line was within that range. The display was a dot matrix LCD, 84 by 48 pixels, made by a supplier in Asia and arriving at Salo in protective trays. It was fragile in a way the polycarbonate body was not. A crack in the LCD was not a recoverable defect. Workers handling the displays wore clean gloves and worked in a section of the line that controlled static discharge. A static shock could destroy the display driver circuit invisibly, producing a failure that wouldn't appear until the phone was in a customer's hands. Final assembly brought together the board, the display, the keypad, the antenna, the battery connector, and the two body halves. Workers seated at stations along the final assembly line fitted each component in sequence, guided by a visual instruction card specific to the current model variant. The back cover clicked into place over the chassis. Then the front cover. Then the completed unit went to the drop test station. Not every unit. A sample from each production batch. The sample unit was dropped in the defined manner, the result recorded, the batch cleared or flagged. Then the units went through final functional test, a shorter version of the board level test, this time as a complete phone, with a SIM card loaded, verifying that the antenna was properly connected and the radio performed within spec. Units that passed were labeled, boxed, and moved to the dispatch area. By 2001, the Salo facility was producing hundreds of thousands of 3310 units per week. The total production run of the 3310 across all variants reached over 126 million units. 126 million phones, each one drop tested, each one passed through a bed of pins. Each one examined by a camera that could see details no human eye could reliably catch. The 3310 was discontinued in 2005. Nokia went on producing phones, the N series, then smartphones, then the long difficult years when the market shifted beneath them faster than they could move. In 2016, Nokia sold its phone business entirely. The Salo factory, which had employed thousands at its peak, closed its doors as a Nokia facility. The building still stands. The town of Salo still remembers what it was built around. The workers who ran the drop tests and the reflow ovens and the optical inspection cameras have dispersed. The phone they built has outlasted the company that made it. There are 3310s in drawers all over the world right now. Batteries removed. Forgotten, waiting, and if you put the battery back in, there is a reasonable chance it will turn on. Not because of the myth, because of what happened in Salo.